The SLOWPOKE is a low-energy, tank-and-pull-type nuclear research reactor designed by Atomic Energy of Canada Limited in the late 1960s. John W.Hilborn is the scientist most closely associated with its design. It is beryllium-reflected with a very low critical mass but provides neutron fluxes higher than available from a small particle accelerator or other radioactive sources. Basic design. The SLOWPOKE 2 originally used 93% highly enriched uranium in the form of 28% uranium-aluminium alloy with aluminium cladding, and then in 1985 a new low-enriched uranium design was commissioned using ceramic UO2 fuel. The core is an assembly of about 200 to 300 fuel pins, only 22 cm diameter and 23 cm high, surrounded by a fixed beryllium annulus on a bottom beryllium slab. Criticality is maintained as the fuel burns up by adding beryllium plates in a tray on top of the core. The reactor core sits in a pool of regular light water, 2.5 meters diameter by 6 meters deep, which provides cooling via natural convection. In addition to passive cooling, the reactor has a high degree of inherent safety, that is, it can regulate itself through passive natural means, such as the chain reaction slowing down if the water heats up or forms bubbles. These characteristics are so dominant, in fact, that the SLOWPOKE 2 reactor is licensed to operate unattended overnight. Most SLOWPOKEs are rated at a nominal 20 kilowatts, although operation at higher power for shorter durations is possible. History. The SLOWPOKE research reactor was conceived in 1967 at the White Shell Laboratories of AECL. In 1970 a prototype unit was designed and built at Chalk River Laboratories. It was primarily intended for Canadian universities, providing a higher neutron flux than available from small commercial accelerators, while avoiding the complexity and higher operating costs of existing nuclear reactors. The Chalk River prototype went critical in 1970, and was moved to the University of Toronto in 1971. It had one sample site in the beryllium-reflected when operated at a power level of 5 kilowatts. In 1973 the power was increased to 20 kilowatts and the period of unattended operation was increased from 4 hours to 18 hours. The first commercial example was started up in 1971 at AECL's Commercial Products Division in Ottawa, and in 1976 a commercial design, named SLOWPOKE 2, was installed at the University of Toronto, replacing the original SLOWPOKE 1 unit. The commercial model has 5 sample sites in the beryllium-reflected and 5 sites stationed outside the reflector. Between 1976 and 1984, 7 SLOWPOKE 2 reactors with highly enriched uranium fuel were commissioned in 6 Canadian cities and in Kingston, Jamaica. In 1985 the first low-enriched uranium-fueled SLOWPOKE 2 reactor was commissioned at the Royal Military College of Canada in Kingston, Ontario. Since then 2 reactors have been decommissioned, and one converted to LEU. AECL also designed and built a scaled-up version called the SLOWPOKE Demonstration Reactor for district heating at its White Shell Nuclear Research Establishment in Manitoba. The economics of a district heating system based on SDR technology were estimated to be competitive with that of conventional fossil fuels. However, the market for this technology did not materialize, and the proposed SES-10 was never built, and the SDR shut down for decommissioning. Marine power source. During the mid-1980s Canada briefly considered converting its Oberon-class submarines to nuclear power using a SLOWPOKE nuclear reactor to continuously recharge the ship's batteries during submerged operations. A good deal of work had been done on potential marine applications of the reactor at Royal Military College of Canada. current applications. Slowpoke reactors are used mainly for neutron activation analysis in research and as a commercial service, but also for teaching, training, irradiation studies, neutron radiography, and the production of radioactive traces. The main advantages are the reliability and ease of use of this design of reactor and the reproducibility of the neutron flux, since the fuel is not modified at all for at least 20 years. The neutron spectrum in the irradiation sites does not change and the neutron flux is reproducible to about 1%. 5 of the original reactors are still in operation. Although all of the technical goals of this reactor were achieved, the lack of foreign sales was disappointing. Royal Military College of Canada's non-power reactor operating license was renewed and will be valid from July 1, 2013 until June 30, 2023. RMCC has operated a small Slowpoke 2 research facility since 1985. A neutron beam tube was added in February 1999 to the Slowpoke 2 facility for radioscopy and tomography operations. University of Alberta's Slowpoke 2 non-power reactor operating license was renewed and will be valid from July 1, 2013 until June 30, 2023. Until 2014, the University of Alberta signaled its intent to decommission the reactor. École Polytechnique de Montréal's Slowpoke 2 non-power reactor operating license was renewed and will be valid from July 1, 2013 until June 30, 2023. The reactor has been in operation for 36 years and is used for research, teaching, neutron generation and isotope production. Saskatchewan Research Council non-power reactor operating license was renewed and will be valid from July 1, 2013 until June 30, 2023. The University of the West Indies International Centre for Environmental and Nuclear Sciences in Kingston, Jamaica continues to operate their Slowpoke 2 reactor, with an aim to convert to LEU as part of the Global Threat Reduction Initiative. Former applications. Dalhousie University applied for, and was issued, a license to defuel and decommission the Slowpoke 2 reactor facility, which was part of Dalhousie's Trace Analysis Research Centre in Halifax, Nova Scotia on August 31, 2011. The University of Toronto's Slowpoke reactor operated from 1976 until December 31, 1998. The University of Toronto applied for, and was issued, a license to decommission its Slowpoke 2 nuclear research reactor facility in 2001.